This question is about trigonometric equations. Part A, show that the equation sine 2 theta plus cos 2 theta equals 2 sine squared theta can be expressed in the form cos squared theta plus 2 sine theta cos theta minus 3 sine squared theta equals 0, 2 marks. So, in the MF19, remember we have the sine double angle and the cos double angle formula. And since, as you can see, the angles we are dealing with, we have 2 theta, and in the equation we need to prove we only have theta, so of course we have to use the double angle formulas. So instead of sine 2 theta, we use 2 sine theta cos theta, and we replace the cos 2 theta with cos squared minus sine squared. And from here it's supposed to be obvious because minus sine squared minus 2 sine squared is minus 3 sine squared. So we get what we need to prove. In case you are wondering, why don't we use the other cos double angle formulas, such as the 1 minus 2 sine squared theta, for example. 1 minus, if we replace with 1 minus 2 sine squared theta, here of course we're not gonna get the equation we need to prove, so that's why. So just keep your eye on the prize, which is the goal, so that's why we use this cos double angle rule. Okay, now that we have what we need to prove, we do part B, solve the equation. So for this kind of questions, first of all, be careful and check whether this equation is exactly the same as the one in the first part, because sometimes maybe instead of 2 theta here we have 4 theta or 8 theta or something, so be careful. In this case it's exactly the same, which means we can replace the equation here with what we have proven in the first part. So now we focus on solving this equation. Now if this is confusing, just simplify things. Let's say this cos theta is x and the sine theta is y, so the equation becomes, this is x squared, this is 2xy, and minus 3y squared. This is just the usual quadratic. You can factorize this. If the y is confusing, just ignore it, and you're gonna get 3x plus 3x minus 1, and then you rewrite the y. So just the usual quadratic factorization. So to solve the quadratic, of course this equals 0 or this equals 0. So from the first factor equals 0, you just move this to the right, so you get minus, so minus 3 sine theta. And to solve this kind of equations, we can divide both sides by cos theta, because cos theta cannot be 0 here, which means we're gonna get sine over cos, which is tangent. Again, it's in the MF19. And we can divide both sides by minus 3 at the same time, so we're gonna get minus 1/3 on the left, and on the right we have just tangent theta. And remember, to solve quadratic equations, trigonometric equations, we gotta find the base angle, the angle in the first quadrant. So we use inverse trigonometry, so we use inverse tangent in this case. And remember, to find the base angle, we ignore the negative, so just the 1/3, inverse tangent 1/3, we're gonna get the first quadrant base angle. And since the tangent theta is supposed to be negative and the domain is between 0 and 180. Only quadrant 1 and quadrant 2 is possible. Of course, we can only use the quadrant 2 angle, which is 180 degrees minus the base angle. So you use your calculator. 180 degrees minus inverse tangent 1/3. You're gonna get this number in 1 decimal place for angle in degrees. And for the second factor equals 0, we move the minus sine theta to the right, so we get cos theta equals sine theta, and then we divide both sides by cos theta. And on the left we have only 1, on the right we have tangent theta, and the base angle is inverse tangent 1. And since the tangent theta is positive, we can only use the first quadrant value because between 0 and 180. So the first quadrant or the base angle value is inverse tangent 1, which is 45 degrees. So we have two solutions. Alright, I'll see you again next time.